Hey guys, how are you? Good morning. Happy Sunday. Hope you're doing well. I can't believe that the countdown timer ran out on me before I joined in. Sorry about that. I didn't turn on my camera quickly enough. But I hope you're doing well. Thank you so much for joining me in this continuing series on the Introduction to Statistical Learning book. This book here, again, this is the book where professional data science begins. So what I'm doing is I have an 8-week series where we're going to cover each one of the chapters every Sunday. This happens to be week number 2, which means that we did chapters 1 through 3 last week, and we're going to do chapter 4 today. And I think the book really lays out data science in a very good way so that you're going to establish a really good foundation for moving on in your data science studies. So thank you so much for joining me. I'm seeing different people on Instagram. I'm seeing different people on YouTube. Really going to get a great turnout today. So let me start by looking into some of the chats. I already see chats already going on all platforms, which is fantastic. And by the way, today I'm also experimenting by pushing out on Kick. I just opened a Kick account yesterday, so I thought maybe I'd push out there. So if you also have a Kick account, feel free to follow me there. But I think that most of you will be following along on YouTube because YouTube provides you with a wider format, which is a little bit more convenient for some of the stuff we do, especially when we get into the classroom view. But yeah, just want to go ahead and get started and, make sure I greet everyone because everyone here is already ready to go. But let me hop into my chat here. Patrick, good morning. Hey, all hoping you're having a great Sunday. Thank you so much, Patrick. Patrick, by the way, is going to be our moderator in YouTube, and he's also one of my moderators in Discord. Really helps me out. So, give a shout out to Patrick when you get a chance. But thank you for being here, Patrick. Rohan, good to see you again. I know you've been attending a lot this week, so thank you so much for being here. Hope you're well. Sayed Salmanziz says, good morning, Mr. Dennis. Good morning to you too. Hope you're well. Rohan says, can you increase the font size during the coding part? Yeah, sure. I think I got to a pretty good font size last time. If not, let me know. But yeah, we can definitely do that. I'll do that for both the code and the terminal. Hamad Javed, welcome Hamad. Hello everyone, I hope you're doing well. Well, thank you Hamad, hope you're well too. Himsteak says, good morning all, good to see you. Rex Riker, our man in New York City, says, hi everyone. Well, hello, Rex. Good to see you, my friend. Rex is also an active participant on our Discord. If you haven't joined our Discord, we have over 50 people now, which is incredible, on the Discord. So if you'd like to join the Discord, you're welcome to do that. The link is in my Instagram highlights. Explore the beauty of nature. Oh, good to see you, my friend. I think you attended all of last week's class. I think you were one of the people that stayed for the whole thing. So glad to see you. Hope you're well. Okay. So I think we are ready to get started. What I want to do is, and by the way, if you haven't introduced yourself, please go ahead and let me know where you're checking in from. And then also, I do like to run my classes with a lot of feedback. So I will be asking questions, throwing questions out to the chat, and please participate as you feel comfortable. It kind of helps everyone learn from each other. There's no bad answers, and I'm not going to call on you for an answer. Just participate as you feel comfortable, but it really helps the overall learning if people, kind of help and jump in and help each other. Rahul Jain, hello all. Lovely to meet you all again. Nice to see you, my friend. Atharva, I don't know what you're referring to. If you want to provide some clarification there, I don't usually help people with homework questions. That sounds like a homework question. Siva Namaste from India. Nice to see you again, Siva. I know you've been on plenty of streams before, so nice to see you, my friend. Hey, you may call me Tim is back. Hello, Tim. I think you took a little break there, but you're back. Good to see you again, my friend. Hi, Dennis from India, Dehradun. I hope I'm pronouncing right. Okay, Palki, good to see you again, Palki. Patrick, I love your reply. That's funny. Yes, I guess people in the chat think that they should be writing prompts so that Dennis AI can write it for them. That's hilarious. I love that reply, Patrick. And Andy Edife? Andy Edifice says, good morning. My name is Anderson. I am a master's student in economics from Nigeria. Welcome. Welcome. I appreciate you joining. We get a lot of viewers from the African continent, so good to see you. Yeah, Rex, indeed. That was funny. I love that reply by Patrick. Ashish, hello, Dennis. Hello, Dennis. Good to see you. Good to see you too, Ashish. Welcome back. Rahul, smart reply, Patrick. Yeah. Patrick gets his name on the board today. He made a good one today. Sai Divya, hello, Dennis from Dallas. Oh, very cool. What part of Dallas? I was based in Dallas for 2 years, like right before the pandemic. I was based in Dallas. Still have many friends there actually. Love the community there. Lots of tech companies in Dallas, at least in the areas where I was. Lots of really good Indian restaurants in Dallas too. So yeah, hope you're well there, Sai. Sonai Muthu says, hey Dennis, I'm also in India. Happy to see you again. Oh, happy to see you too, Sonai. Welcome back. SA Work says, dear sir, I'm new here, just curious to know about statistical strategies in machine learning. Well, you're in the right place. You're in the right place. The book that we're going to is called An Introduction to Statistical Learning. So you're in the right place for it. And, we're going to go ahead and, just keep on going with the book. And, you're welcome to join us for as long as you can. Again, I've told people, if you need to go, you can always come back. We know these sessions tend to go at least 2 hours. We haven't gone anything short than 2 hours, really anything short than 2.5 hours. So yeah, come and learn as much as you like, and if you need to step away, that's totally okay. My hair is not cooperating this morning. Ugh, I didn't put enough product in it, eh? I always, shower fresh and everything right before these streams, and I didn't put enough product in my hair. So you're going to have to forgive my hair. It looks terrible this morning. Sincerely, Sadiq says, hello, Dennis. I'm Sadiq from Raleigh, North Carolina. Oh, very cool. I have family in Raleigh. Let me know what part of Raleigh you're from. Lots of tech companies there in the Triangle. In Raleigh. Hello, Dennis. How are you doing? Happy Sunday from Nigeria, from Michael. I'm doing well, Michael. Thank you so much for asking. I got up early. I've been up since 4:30 in the morning. I take my dog to the dog park. He runs around and has his fun, and then I go to Starbucks, come home, do some work, get ready for the day. Just so I've had a good morning. So we're gonna continue that with having a good class today. Nazish says, hi Dennis, really excited to be part of this session. I'm excited too. These sessions are fun. I hope they're informative for everyone. Honestly, it helps me too to kind of go back and look at some of these concepts in the book. I've had this book for a very long time. I'm embarrassed to show you the back because it's so dirty, and it's a book that I refer to quite a bit. But it's been helpful for me too to also go back and remember just little different things like, oh yeah. And, actually, and now since I have a lot more experience in the industry, it's also helpful for me to go in there and say, yeah, I want to teach this because I know I've used this. I know this is important. And then I can look at other things and say, yeah, that's a good chapter, but maybe not as important because, it's been like multiple years and I haven't used it, So it's been good for me, too, to kind of go back and help these things, okay? Yes, somebody help Atharva. I think Atharva might be AI. Maybe we have it backwards. Maybe he's AI. So, because it sounds like he's just repeating the scripts from some of the previous sessions and some of my reels because these are some of the interview questions that I asked. So yeah, somebody help Atharva. Somebody guide Atharva in the right direction. All right, guys. So now that I'm seeing some of the hellos slow down a little bit, let's go ahead and get started, huh? So I'm going to switch over to my classroom view. And what I think I'm going to do, Hamad, that's a good point. Yes, something is not being understood here by Atharva. Let's all try to help him out. So I'm going to switch over to my classroom view. And I'm going to bring up my slides. And it looks like I might have to redo my classroom view. Give me just a second here, guys. For some reason, I have to refresh this every once in a while. Okay. All right, so this is my classroom view. Again, if you're on Instagram, maybe not the ideal platform, feel free to go to YouTube so you can get a widescreen view. But what I'm going to do is, today our focus is on chapter 4 of the ISL book. If you don't have the physical book, you can always go to the author's website, statlearning.com, and download the PDF. I am working from the the ISL book that's for the R version, and this is their first edition. They've updated it since then, but it's the edition that I have, so it's the one I feel most comfortable teaching. Don't worry about the language, because if you haven't heard, the twist that I'm doing here, to honor the author's work, is that we are doing it with AI. We are not going to be doing any native code. We are going to be using AI to write all of our code. So it's going to be, a little bit of a twist, a little bit more fun that way, okay? So here's what I want to do. I'm seeing a lot of new people in the chat. Maybe you didn't come to the last session. So what I want to do is I want to go ahead and I want to start by doing a review of the previous slides. Or at least the introduction slides, because I want to make sure that we're all on the same page. I know a lot of you also attended last week, so I'm going to keep it a little, I'm going to keep it quick for the introduction, but I do think it's good for us to see that, just to kind of get all of us on the same page, okay? So in my introduction, I want to cover the philosophy that I'm going to use for the class, a kickoff as far as how I see the class going, and then the agenda for everything that we're going to do for the remaining weeks, okay? So, data science is a very serious study. It's a profession that you have to dedicate your life to. There is nothing that disappoints me more than when I see these, hack the interview or these shortcut sheets on LinkedIn making somebody think that they can become a data scientist in a month after reading a couple of sheets. It's a very serious profession. I equate it to being like a doctor or a lawyer, where you have to study a lot, and then after you finish your study, you're still going to learn a lot on the job. So for me, if I don't like that people are cheapening the profession by doing these hacks, then it's up to me to contribute and kind of help the data science ecosystem by teaching what I think is relevant. And that's really the point here of this course, that I want you to understand that I'm not offering any shortcuts. I'm not offering any hacks. It's going to take work to become a data scientist. But having said that, I assume that you want to approach this in a professional way. We're not just looking for a job. We're looking for a career. We're looking for a profession. So that's really kind of where I'm approaching this. In addition to that, it's also important for a data scientist to maintain flexibility in their thinking and carry that for the length of your career. You should always be open to more learning, different approaches, different thoughts than your own, so on and so forth. So that's part of also the philosophy that I want to encourage in you for attending a course like this, okay? I teach with the Socratic method. That means that I ask a lot of questions. If you post a question in the chat, I might reply to you with a question, because that keeps the conversation going, and it kind of helps you kind of think on your own 2 feet, not to always just have the answer, kind of spoon-fed towards you, right? So I want to make sure that, you also understand that, I'm asking you to listen and participate as much as you can, I know that most people might be watching on their phones or things like that, but try to make this a dedicated time so that you can participate back, because I think it really helps you. And it also helps you to read the comments from everybody else, right? To read the answers from everybody else, to read the questions that you have, right? I think all of that really helps. I am not promising that you will be ready for a job after this, but you're going to have a pretty good foundation. You're going to have a really good foundation to continue your study and keep going forward with more of the things that you're going to learn and some of the things that aren't taught in this book. There's plenty of things that aren't taught in this book, and the authors fully acknowledge that, right? So I want to make sure that you have that understanding that this isn't for a job, but it is for a pretty good foundation. And again, it's for professional data science. This isn't just somebody who, I really need a remote job, or you just want to rush into it, right? It's intended, to help cultivate the professionalism that it takes to become a data scientist. So we are doing the Introduction to Statistical Learning book, and my intent is to honor the authors, because I want to be intellectually honest throughout this process. I'm not here to copy anybody's work. That's not my style. That's not intellectually honest. So we know that the authors have developed the ISL book for R, and we know that they've also developed the ISL book for Python. That's ISLP. So how can I build upon that work? Because that's the way I want to honor the authors. And what we're doing, I'm introducing ISLA, which is ISL, the ISL book with generative AI tools. This is rooted in what I call the blank screen effect. If you're a data scientist, a software developer, and other professions too, like lawyers, real estate agents, advertising executives, you should never start from a blank screen anymore. Gen AI has changed that. If you are starting from a blank screen, then you are a dinosaur. Your job will be eliminated. This is what I truly believe will be the future of data science development. You will not write algorithms. You will supervise ChatGPT writing algorithms for you. I'm 100% convinced of this. So we might as well get a head start now and start working with some of those tools and start working in that mode where we think of ourselves, this is fine, where we think of ourselves as developing the skills to do the managing of AI tools, not necessarily of writing our own code. So we are going to learn the concepts from each chapter, and then we're going to use AI to help our understanding of that and to handle the prompts that we create. And then our job will be to edit and refine the code to a deliverable state. We will be editors of code, not writers of code. And by the way, we already saw that. We saw that in last week's session. For those of you that attended, you saw that ChatGPT made a very fundamental, very simple mistake in one of the code scripts that it generated for us. So the AI tools are not perfect, but they're close enough. So we still have to be smart enough to be an architect and understand what we need, understand how we're going to prompt the AI, but then also be able to understand when it makes mistakes. So that's what we're going to be doing, okay? So I'm going to provide the general concepts that I pick up from the chapters. More specifically, the stuff that I know we use in the real world of data science. And in some cases, I'll point out stuff that maybe you don't use. That's going to be the case today. I'll point out some stuff that maybe you don't use, right? So that's kind of my intent. I'm not going to sit here page by page and copying the author's work. That's not honest. I'm going to give you the highlights as I see them as a chief data scientist. Maybe things I ask questions on, maybe things I know we've used, maybe like theoretical things I ask in interviews. I'm going to just kind of like be curating those out of the chapters and presenting them to you in these slides. And then we're also going to do 1 to 2 lab exercises. And then I also leave you with some like additional thoughts of where you can take this further. So if you want to do some of your own study, I'm gonna leave you with a couple nuggets to say, well, what about this? What if you extended it this way? What if the problem was X instead of Y? And how would you modify what we did today to do that? I'm gonna try to leave you with some of those things. But again, the work will be on you. The work will be on you to take that and run with it, okay? And then finally, as I said earlier, I'm working from ISLR version 1 that's available as a PDF. Let me go down here. Patrick has been kind enough to already post it in the chat. That is where you can download it from. And also, again, to honor the authors, that's also the author's website. That's the official website for this book. So please go there, support them. They've created a wonderful book. I'm not trying to steal any of their book or any of the idea. So please go to them, and that way we can all honor their work, okay? Yes, so if you want to know which one to download, there's multiple PDFs. Go ahead and download ISLR version 1. Again, it's just the one I like. It's the one I feel most comfortable with. If you want to download the other ones, it's up to you. But I will be teaching, and what I show on the screen when I do show the PDF, it will be the version 1 of the R code version. Okay. Okay, so let's go to the next slide. Yeah, so you're encouraged to read the PDF prior to each session. So today we're on chapter 4, and we're going to do one chapter all the way to the end. I believe there's 10 chapters in that version. So we're going to go through today and in the coming another 6 Sundays after today. Everything is as a live stream. I completely hate the thought of sitting here and recording something for you guys and then you having to see it. That's not my style. I'm never going to record content like that. I think that's boring. So it'll always be a live stream. I love seeing you guys in the live stream. I like highlighting your chats and things like that. So this is the format we're always going to do. I refuse to teach in any other way. I make the announcements on Instagram. I also post the thumbnails and the session ahead of time on YouTube. So make sure you subscribe to my YouTube, and when you see the new thumbnail come up, click on notify, and YouTube sends you an alert, I think like 5 minutes or 10 minutes before my stream starts. So YouTube will take care of notifying you and say, hey, the next class is starting or whatnot. So feel free to click on that, and that way you'll never miss a class. Or I keep them up on YouTube. I host, it's in my, I think it just converts to a video. So you can sit there and watch it. Maybe you missed a particular portion and you want to review, whatever the case may be. Okay? Okay, so this is the chapters that we're going to cover. And give me just a little break here, guys. Hold on. Sorry about that. I had to sneeze a little bit. So these are the chapters that we're going to be covering. And then also, I do want to emphasize this again, because some of you, weren't here last week, and I think of this as like, if you were to go to an Olympic athlete, like a javelin thrower, right, and you were to take lessons from them, they're probably going to focus on a lot of the general stuff, right? They're going to show you, how to hold it, how many steps to run, at what time to throw the javelin, right? They're going to do that. But you, as a beginner, you might have questions beyond that and say, well, like, why do I put my wrist in this way? Or like, why does my arm have to be like at this angle and not this angle, right? And that javelin thrower, that expert athlete is going to tell you, I don't know, I've just always done it that way. It's just kind of habit, right? There's things that they literally can't explain because that's just the way they've always done them, right? So I feel the same way because I've been a developer and in the field and a data scientist for a long time, that sometimes I may be glossing over things that to me are just like natural things that I haven't thought about in years, but to you, they might still be new. So feel free to, kind of call me out on that. If there's something that's not clear, I encourage you to come back with questions and just, let me know what, something needs more explanation or whatnot. But, that's just the way my mind thinks because I've been at it for so long, right? I don't think about like the small little individual things. I just do them. I've just done them for years. So I hope that's clear. And, again, just encouraging you to feel free to stop me and keep going. Okay? All right, let me check the chat here. Patrick's doing a great job of answering it. Okay, yeah. It looks like Patrick's handling all the questions. If there's anything else that's needed, let me know. I'll stop the session. But Patrick, thanks so much for answering all those. All right, let me see if there's anything else in the setup that we should go over. Otherwise, we're going to jump to chapter 4. Okay, so this is the general concepts. Yeah. So I'm going to come back to this slide because there's one more thing I want to cover with you guys. This is it right here. Okay, so real quick, again, I realize that this is a repeat for those of you who attended last week. I apologize, but I'm seeing some new names, so I want to make sure we go through these. In chapter 1, this is important, you're going to find these 4 tenets or these 4 premises that the authors put forward. And I really like those premises, and I want to make sure that you also understand them because I think they're important. So the first thing is they talk about how they fully acknowledge that there's more models out there. There's more to learn. There's plenty of things out there for you to tackle. But they have narrowed it down to what they think are the most flexible and most widely applicable models across industries, right? See, that's what makes this book so good, that they recognize that their work is not just academic. They realize that it will be used out there in business applications. So the authors clearly acknowledge that you're going to be working for somebody, you're going to be in some sort of business environment. So these are the most widely applicable in industrial approaches to data science. So I think that's really important to understand because one, it helps you understand how these chapters came to be, how they chose these chapters. And two, as I said earlier, finishing this book, finishing my course, finishing any class is not a straight jump to getting a job. It's a good foundation. You're still going to have to build upon it. You're still going to have to, learn more about different things, right? For example, I don't want to speak for them, but I think the authors would agree that this is not necessarily a good book to learn neural networks, right? They cover neural networks very little in this book, right? So you're still going to have to go out and do your work, but the authors do try to provide the most applicable models in here. Second, no single approach is going to work well for any given problem that you have. They're going to have trade-offs, but most importantly, this is where the experimentation in data science begins. Some of you were in the chats earlier this week where we talked about what's your favorite machine learning model, right? And that's a trick question. You shouldn't have a favorite machine learning model because there is no favorite. Every piece of data, every project, every endeavor you're going to take in data science is unique. So you can't say, oh, that data looks like some data I worked on last year, so let me use the same model. No, right? No approach will work well in all situations. You always have to run a proper experimentation process. That's the science part of it, right? So keep that in mind. Super important premise. This one is also very key. I'm copying directly from the book. We assume that the reader is comfortable with basic mathematical concepts, but we do not assume a graduate degree in mathematical sciences. This is so key. And we've seen some back and forth. One, I get a lot of private messages from a lot of you who are intimidated by the math. Some of you put that in your comments. And sometimes we have to go back and forth in the comments with some people who just refuse to believe this. I guess there's a lot of linear algebra supporters out there that can't handle their world being rattled by by hearing this. But the reality is that the math that you need in data science is way overstated. It's much better to understand the models, what they do, how to use them, and how they can apply to different problems, and how you can use a series of those models to find the most applicable for your individual problem. And again, this is not me saying this. I said it before the office because I truly believe in this. I've seen it. I've seen it in the people that I hire, in the projects I run, the way we execute those projects. You don't need this amazing graduate level, PhD level worth of mathematics, right? The time when companies only hired PhDs in mathematics has come and gone. It hasn't been that way for at least 6 to 8 years, right? And then finally, the authors, again, coming back to their acknowledgement that we're all going to be working in the real world, the book focuses on solving real world problems. And I love that because that's what I focus on too. That's what I try to center my content on. I've already been in the industry. Now I'm reaching my hand back to help all of you, but I'm going to do it with that twist of this isn't a school exercise. This is the real world. All right. We are out there, earning a paycheck from our skills, right? And this is what's required of that. That's different from academia. Okay? So closing with that, I encourage you to read the ISL book. If you also want to know more about data science in the real world, I also will point you to my book, Your First Year in Data Science. I just published it last week. I'm #1 in the new releases in the data mining space on Amazon, so I'm really proud of that. So if you guys are interested in learning more about the real world of data science, there's a whole book on it. Really proud of it. I went through a lot of work to make sure I produced a quality product for you guys. It's all in color. All the charts are in color. So if you're interested in that, I'd appreciate your support. It's available on Amazon globally. I've made the ebook version affordable. So please consider the book, and I appreciate your support. All right. So these 4 tenets are what I like from the author. And I think that's the last part of the first chapter. That's the last part I want to talk about because I think it's super important. So feel free to revisit that. Okay, so now let's get started. I'm going to reuse one of my slides from chapter 1. And this is our first opportunity for participation here, guys. So listen up. I'm seeing a lot of YouTube folks, which is great. If you're on Instagram, feel free to join us. You're welcome. You're welcome to also participate and give answers as you see fit. What are quantitative outputs, and what are qualitative outputs? Give me an example. Give me your definition. Give me your elevator pitch, whatever you'd like. And then if you want extra credit, tell me what's clustering. All right? So I'm going to give the chat here a minute. Let me know. You don't have to answer all three, by the way. You can answer just one if you're comfortable with. But what is quantitative? What is qualitative? And what is clustering? Answer however many you feel comfortable with. I'll give you guys a minute while I take a water break here. What do you guys think? Qualitative, quantitative, and clustering. Give me some definitions or examples. And/or examples. All right, Rahul, thank you so much. Rahul is giving us our first answer. Quantitative means which can be measured using numbers like count, average, sum. Okay. Explore the beauty. Wonderful. He's going to give us, he's volunteering for qualitative. Qualitative outputs can involve a set of land cover classes, water, built up forest. Okay. There's a name for that. Explore the beauty. Give me you understand what it is, but there's a name for some, like water, built up forest. I love the example. So to be fair, you filled that because I did ask for examples, but give me the name for that. There's a name for that, okay? Mamiya says when response variable is expected to be numerical, it's quantitative. Great answer. I'm on board with that. Quantitative output is numerical output, more so predicted number or figure. Okay, being, I'm on board with that. Clustering means grouping items in different classes. Nice, Rohan. I'm on board with that too. So Rohan volunteered for clustering. I like it. Nazish says qualitative. Do these individuals have a lung disease or not? And is in the form of yes, no. Ooh. Chat. What do you guys think? That's an interesting answer. Nazish, I love the way you're thinking about this. You had, Nazish, you had me at lung disease. You lost me at yes or no. Is it always yes or no? What do you think? What do you think, Chad? Is it always yes or no? You know what, Nazish? Ultimately, don't misunderstand me. I love your answer because it fits perfectly with what we're going to talk about today. But is it always yes or no? Tell me, guys. Quantitative like age, qualitative like gender. Yeah, okay. I'm on board with that. Ah, Patrick. Patrick is presenting us with a key word here. Qualitative is categorical. Is that right, chat? One, is that right? And two, are categories always yes, no? Because we've been told that it's also just yes, no, right? Is that the case? But Patrick, I'm on board with your use of categorical. That's a key word, right? We should be thinking about that. After all, today's chapter is categorization, right? So I like it, Patrick. SID official, deal with numerical quantitative, and deal with numerical is quantitative, and with variable qualitative. Clustering means grouping items into different subset from a set. Yeah, okay. I'm on board with that. I think that clustering can have more uses than that, but yeah, I'm on board with that. Qualitative is y and quantitative is how much? And quantitative is how much? I'm on board with your quantitative. Qualitative is y. Is it always a y? I don't know about that. Is it always a y? I think it could be more flexible than that. What do you guys think? Mamiya says, when a categorical output is expected from response variable is qualitative. Love it. Love it. That's a great brief answer. Love it, Mamiya. I think you're on the right track with that, my friend. Rahul says clustering is when you group data with some similar features. Yeah. I like it, Rahul. I'm on board with that. Clustering is grouping different classes together. Yep. Yep, that's a good one, Bing. Clustering is grouping two or more classes based on their characteristics. Yeah. Yeah, Rahul adds for qualitative. Qualitative means which cannot be measured with numerical accuracy. Text or image of categorical groups would have to be interpreted. Yeah, that's one use. But I just don't want you guys to think that that's the only use. There's a lot of uses for categorical, right? Or for qualitative outputs, I should say. So yeah, I'm on board with it, Rahul. Just make sure you understand that there's more uses than just categorical groups, okay? Or you can think of it more than just groups. Bing says categories can be more than yes or no. I agree. So that's coming back to the earlier response about it being in the form of yes, no. Categories can indeed be a lot more than yes or no. And we're going to talk a little bit about that today. So I love the fact that we're hitting on that. I love the fact that Nazish brought up that yes, no, because that's really key. So yeah. Ashish says quantitative outputs, numerical outputs, qualitative outputs is categorical. Categorical output clustering is grouping without any explicit labels. Ooh. Hey, and by the way, guys, please try to not spam the chat. If you give an answer and it appears on your screen, I guarantee you that I see it. It just takes me a while to scroll down, okay? But please don't spam the chat. Okay, so is clustering... So you're saying clustering is always grouping without any explicit labels. Is that true, chat? Is that true? I don't know. I don't know if I'm on board with that last part. But you guys let me know what you think. And we're going to cover some of that a little bit today. Okay. So yes, no indicates binary classification, but we could also have different categories: lung disease, common cold, placebo, etc. Yeah. That's good. That's exactly right. So you know what? I love Patrick's last comment there. It's a great segue for us to go into the slides for today. So let's consider this the end of our initial review and kickoff. And now we are into categorization, chapter 4. So everything else, most of the things from here on in, you'll be able to find in chapter 4. I'll tell you when you can't. So I'm going to give you my chapter notes. I'm going to give you a framework example. We're going to walk through a coding example, and then I'm going to leave you guys with some self-study. Okay? So, what is categorization? Basically, it's what we just went through in the chat right now. It's talking about how not all measures are quantitative, right? There's plenty of use cases where you're going to need a number value back, a quantitative value back. But there's also a lot where you don't need a quantitative value. You kind of need a category, right? You need that qualitative output. So last week in chapter 3, we looked at linear regression, which is excellent for qualitative outputs, or at least we saw it being used for quantitative outputs. We saw it being used for quantitative outputs quite a bit last week. But it can also be used for these qualitative outputs, right? So this chapter focuses on logistic regression, linear discriminant analysis, or LDA, and K nearest neighbors, or KNN. Because all of these are valid models for those times when you need qualitative outputs. Okay? So, next question for the chat. What is logistic regression? Think about the conversations we just had in the chat, right? We had some great answers, and we're thinking about qualitative outputs. What is logistic regression? What do you guys think? Why would I be bringing up logistic regression right now after the conversation that we just had? Give you guys a minute to think about that. If you don't know, it's perfectly okay to say I don't know. That helps me too, because it helps me gauge the level. But I want you to kind of just, do this mental exercise to kind of tie these things together. Why am I bringing up logistic regression right now, given the conversation we just had, and given that we're talking about these qualitative outputs, right? What is logistic regression? Okay, so Shantanu says logistic regression is about classification of categorical data. Okay, okay. Give me a little more. You're super close. Give me a little bit more. Take me just one extra step further. Because you're so close, Shantanu. You're so close, but give me just one more extra step. Or anybody else who wants to build on his answer, give me one extra step. Give you guys another few seconds here to think about it. Being says logistic regression is one of the classification algorithms used for categorical distinction outputs. Oh, you're just as close as Shantanu. You're just as close as him. So go one step further. Go one step further. Oh, Mamiya, I love the way you put this. Classification of categorical data based on probabilistic approach. Yeah, I love your mention of the probabilities, because that's going to be key for what we're talking about today. But still, give me one step further. One step further. You guys are so close. And there's a lot less participation on this one, so I'm going to assume people, don't quite know what logistic regression, or at least aren't comfortable expressing it, and that's okay. That's okay. We're going to try to change that here in this lesson. But I'll give you guys another 10 seconds here. Oh. Explore the beauty. You're so close. Go one step further. You're so close. All right. Shantanu, yeah, you got the answer in the long run. So good job, Shantanu. Yeah, so I skipped over Rahul's answer because he's giving probably the best answer that I'm seeing here, right? Actually, Rahul and Patrick essentially have the same answer. But yes, the key here is that Rahul mentions the yes or no questions. Or Patrick, calls it the binary questions, binary classification. And that's exactly right. When you hear logistic regression, you should be thinking about binary classifications. Two classifications, yes or no. Yes or no, true, false, is a member of the class, is not a member of the class, right? So I think it was Mamiya that talked about the probabilities, right? So that's exactly what logistic regression is. And by the way, guys, I started off like this, one, because I think it's a nice tie to the conversation we had, and kind of understanding the qualitative nature and stuff like that. And somebody had mentioned the previous question about, it can be a yes/no thing, one or the other, right? So that's all on the right track. But another reason I asked this is because Believe it or not, this is a popular interview question. People will ask you, what is the difference between regression and logistic regression? I've had that question in interviews before. I've never asked that question. Perhaps I should work it into my interviews. But I have had that as an interview question before, where they will ask you, what is regression and what is logistic regression and what's the difference? So you should be prepared to know those types of things, and hopefully you will be after this and after so much more study, okay? But that's what you should be thinking about. You should be thinking about as soon as you hear logistic regression, you should be hearing, okay, I have two categories, so this is a binary classification, and I'm going to be receiving a probabilistic answer. Okay, those are the three things that should come to you when you think about logistic regression, and that's essentially what I have shown here, right? Sorry guys, I have to take these camera breaks because I'm sneezing. I apologize for that. But when you're thinking about logistic regression, you should be thinking about binary yes/no decisions. And again, whenever you see quotes, that means I'm pulling direct from the authors. The authors say it models the probability that Y belongs to a particular category, right? A particular binary category, a particular yes/no category. Another way to put it is that you know what class you're looking for. So the answer is, what is the probability that Y belongs in that class? So does this person have cancer? Yes, no. Right? Is this person a potential client for our sales? Yes, no. And then the answer might be 0.7. And then that gives you a probability that that person does have cancer, or is a potential client, or things like that. Okay. So Y equals mx plus b is something that we learned last week, right? And you should always be thinking about Y equals mx plus b for the rest of your data science career, because it really explains a lot in data science. How it relates to logistic regression is that over on this side, on the left-hand side of this graph, this is pretty much a standard regression method approach, right? A linear regression approach. The challenge is that linear regression can give you negative values, and it can also give you an unlimited number of values, right? But since we know that we're logistic regression, we're talking about probabilities. I didn't mention this earlier, I'm sorry, but the fourth thing you should think about when somebody tells you it's a logistic problem is that your values are between 0 and 1, because it's a probability, right? It's you'll see how it's a proportion, right? So you should always be thinking of values of 0 and 1. So therefore, a linear approach is not going to work. That's what this, the right side graph shows. That we're going to use an approach that's going to always give us values between 0 and 1, no matter what data we put in. So that's another really key difference between the regression we learned last week and most regression approaches versus logistic regression. We're going to modify our math a little bit so that we're always getting a proportion, a probability of class membership. So in this case, the authors were using a loan company and the probability of default, which is the y-axis, and then the balance, which is the x-axis. So these numbers is the value of the person's balance, the client's balance, and then this shows their probability of default, right? So this is also a good opportunity for review here. There is a name for what the balance variable is, and there is a name for what the probability of default is, right? Or if you think about this formula, tell me which one is the X and which one is the Y. And again, there are proper, data science names for these. They're on the next slide, so before we move to the next slide, let's just take this as a little bit of a touch point, right? What is the name for these variables? So if you're new to data science, this is a good opportunity for you to learn too, right? So what do you guys think? Yeah, Patrick, thanks for handling that. Guys, I push out on as many platforms as I can to let you know that the streams are going. But the best format is on YouTube, because YouTube does give the wide version. Unfortunately, Instagram only gives the vertical. So I understand that on Instagram it may not be convenient. That's why I push out on multiple platforms. So please, switch over to YouTube, as Patrick and other people are suggesting. There's only so much we can do here, guys. It's a limitation of Instagram. So give you guys another minute there. There is a name for the balance variables and the probability of default. How do they fit into this formula? But there's a name for these. I understand this is a little bit of a beginner question, but it's good. We have different levels in the chat, so let me know. Lakshmi, is it Lakshmi Matella or Lakshmi Matella? Lakshmi Matella, I don't think I've seen you in the chat before, but you're coming in strong. You're coming in strong with a perfect answer, right? X is the independent variable and Y is dependent. Perfect answer. That's exactly the answer we were looking for. So good job on that. I've never seen you in the chat before, but coming in hot. Explore the beauty of nature says Y is the response variable, X is the predictor variable. Perfect. That's another way of saying it. Response and predictors, certainly valid. Shantanu, yep, you got it. Patrick, X is the independent variable, balance. Yep, and Y is a dependent, probably the default. That's exactly right. Yeah, perfect. You guys got it spot on. So let's move forward on that. Another thing I want to mention to you guys, super important principle here, guys. Write this one down, okay? You'll note that, as I said earlier, the binary is for the yes, no. You're always going to get a value of 0 and 1, right? You're always going to get a probability that it belongs to a class or not. So in this case, staying with the author's example, it's going to give you a probability of default. Here's the client's account balance, and then we run it through the model, and then this is the probability of default. Like I said earlier, it might give you an answer like 0.7. Now, the challenge with that is that you have to translate that into some business impact. All right, I'm giving you the real world stuff here, guys. This is why this is important. Just because it's 0.7 doesn't mean it's an answer. And you can't just say, well, we'll only take the people that rate as a 1.0, right? Because then you're still missing a lot of people who have pretty high probabilities of default, right? So what ends up happening is you're going to have to set a threshold and say, okay, we think at 0.75, that's way too much higher a probability. That's when we're going to say deny the person, right? Or whatever measures your loan company would take for that. But who says it should be 7.75? Maybe it should be lower. Maybe it should be higher. You don't know that, right? So I'm using this to illustrate that these are the times where your model answer is not the answer that you give to your clients, to your stakeholders, to your colleagues on the business side. This is where the work of interpreting your results takes over. Super important, guys. This right here is what separates the okay data scientist from the great data scientist. Because an okay data scientist, or even a below average data scientist, takes this graph and puts it in a chart and emails it to the stakeholder. Bad, right? A good data scientist goes out and says, okay, I'm going to pick values at 0.6, 0.7, 0.8, 0.9, 1.0. I'm going to look at those balances. I'm going to look at the number of accounts, and then I can come up with projected losses at each one of those levels depending on what the business chooses, right? And then keep in mind that each one of those also has a potential loss in revenue because at those levels you have a different level of clients that are paying, that you are accepting, right? Not just the rejection side, but the ones you are accepting, that's your revenue, right? So I'm kind of taking this little pause to highlight that with you guys, because again, this is where kind of like the real data science separation begins, right? Like the statistics and math nerds just stop at this chart, but the good data scientists take it a step further and say, I'm going to translate this into business results. This is like this is where, like, you know, in my book, I call this the result interpretation or the model interpretation. And this is where that work begins, where you're going to say, hey, I'm just giving you the probabilities, but this is what it means. If you go ahead and install this threshold for when you're going to reject clients, you know, or deny a loan or whatever the case may be, this is what it means for the losses. This is what it means for our revenue, right? So I kind of want to stress that with you because, you know, this is where like that real work of data science begins. You never send these results to the business. You send them your interpretation of those results. All right, so everybody with me? I really hope that sticks with you guys, because that's what separates the below average data scientists to the better data scientists. All right? And then the great data scientists can stand up in front of them and run a whole presentation in front of them, right? That's a whole other skill. But that's really kind of what separates the below average to a really good data scientist, to be able to take these probabilities and make them mean something for the business. All right, you guys with me on this? Give me some feedback in the chat. I love the way you guys answered. I'm loving the participation. You guys are doing fantastic, so let's keep going. But give me some feedback in the chat if that resonates with you. All right, let me go up here. All right. All right, so tell me about this formula. What do you guys see? I see a couple things that are jumping out at me. What do you guys see in this formula? What do you guys see? All right, good. I'm seeing some good feedback in the chat. Okay, it looks like that is resonating with you guys. Well, good. You know, because that, again, that's me giving you that real world insight, right? The books aren't going to tell you to do that, but that's what you learn when you're out in the field. Okay. Okay, so Explore the Beauty says logistic regression formula. Yeah, but tell me more about it, right? Aren't there a couple things in here that kind of jump out at you? Okay. Patrick and Rahul, are you guys like copying off each other's work? You guys hit it exactly right. The equation of the line and the exponent, right? Both Patrick and Rahul came up with that answer really at the same time, right? That's exactly right. Look at that exponent. What is it? It's y equals mx plus b, right? As I mentioned to you guys last week, you know, the authors use, you know, the Greek alphabet for this. You know, I learned it in a different way, and I've seen it expressed in the way that I do it. That's why I always stick with y equals mx plus b. But yeah, that's exactly right. They're using the exponent as the formula that we've already seen. So at first look, this can seem a little bit intimidating, but it's just y equals mx plus b used in a different way. Okay? Ashish says it squishes the output between 0 and 1. That's exactly right. That's the second thing you see, right? It creates a proportion, right? This over this means it's a proportion. And you're always going to get a value between 0 and 1. That's exactly right, Ashish. That's the other answer I was looking for. Because then this over here, the output, right, makes sense. Because this represents the probability of X belonging to the binary category, the yes, no, the true, false, the cancer, not cancer, right? So that's what should be jumping out at you, right? Where it's an exponent and it's a proportion. It's a 0 to 1 value. So, yeah, Rahul. Not only was the timing amazing, is that you guys also gave nearly the exact same answer, right? Like your answer is just like your two answers are variations of each other. That's crazy. Excuse me, guys. I guess I have my allergies acting up or something. Sorry about that. But yeah, you guys are giving fantastic answers. But that's exactly what you want to be thinking about, right? The math can seem a little bit intimidating, you know, when you hear about these, like this different function you have to use for the output and all that. But it's just y equals mx plus b. That's all it is, right? All right, let me go to the next slide. So here we're just reinforcing what we just went over, right? Px is the probability of y belonging to the class. X is the independent variable, as you guys previously correctly identified. We also did the independent variable is x. B is the coefficient, or the first beta 1 is the coefficient, and beta 0 is the intercept. Right? And then down here, I think it was explore the beauty of nature. Yeah, so explore the beauty of nature. I think your answer is more like this, right? Because just like we saw last week, you can also have multiple independent variables, right? You can have multiple independent variables to determine one dependent variable. So yeah, so explore the beauty of nature. You're on the right track, my friend. But yeah, you can have as many x's, as many independent variables as you need. And most of the time you will, right? It's rarely just one, right? But yeah, so I like the way our conversation has tied into this slide, because this really should be kind of connecting some of those thoughts in your mind. All right, let's go on to the next slide. So far, we've talked about qualitative outputs. But what about the inputs? There's going to be times when you're going to have a situation where you need to use a binary value as an input to a model. Not an output, but an input. And is that possible? You guys let me know. I mean, you're kind of seeing it on the screen, right? So let me know what you think of this, and let me know if you can think of a scenario where you would need that. Satya, you can mostly find me on YouTube. That's probably the best platform, but I'm also on LinkedIn and on Twitch. And really all three of those will give you a wider screen format. So Twitch, YouTube, LinkedIn, you can find me on those, Data Science with Dennis, and that'll give you a wider view. So what do you guys think? Are qualitative inputs useful? You want to give me an example of one? Give you guys another minute here. Yeah, Rahul's giving a great answer. Yeah, Rahul's giving a great answer. Where you want to predict if a particular demographic feature is responsible for a customer being poor, rich, or whatever outcome. Yep. Yeah, demographic features is one of the ways that this is commonly used for any number of demographics, or maybe regional if you live in certain regions or states or whatever the case may be. So yeah, so the answer really is that qualitative inputs are very useful. They're very useful and they're very common. And really, I don't want to single out any industries or any like particular business cases because there's so many. You're going to use this virtually in any industry or company that you end up at. Qualitative inputs are very useful, and that's where dummy variables come in. So dummy variables are basically binary values. Are they part of the demographic or of whatever category you want to come with, or are they not? So that's where you see, if you look at the two formulas, the difference between the two formulas is the very end, right? The 1 or the 0. In this case, they're looking at students and their probability of default. So here, the person is a student, or here, the person is not a student. Member of the category, not a member of the category. So a member gets a 1, a non-member gets a 0. Right? So dummy variables and binary values like this are extremely useful. You're gonna use them quite a bit. Qualitative input are useful. For example, which city is someone from? Does logistic regression still work? Yes, it absolutely still works. You're seeing it on the screen. It's the same formula, right? You're still using the y equals mx plus b as an exponential. It just so happens that one of your x's, or one of your independent variables, is either a 1 or a 0, no other value. That's the dummy variable part of it, right? That you're saying it's either 1 or 0. It can't be anything else. It's either a member of the class or it's not a member of the class. So yeah, you're seeing it right up on the screen. Same formula. It's just that it's an x, right? The x is a 1 or a 0. The independent variable is a 1 or a 0, right? Satya, nice to see that you made the switch to YouTube. Yeah, guys, I apologize for that. I push out on Instagram because that's where my biggest audience is, but definitely join my YouTube, subscribe, click on the notification. It'll tell you when the class starts, and it'll give you a nice wide format. So glad you made the switch, Satya. Hamad says we have to convert qualitative inputs into binary. Yes. For the regressions that we're doing, yes, you do. That's not always the case, and we're going to talk about times when that's not always the case as far as binary, right? Because there are going to be times when you need more than the binary class, right? But there are times, but yes, but for regression and in the examples that we're talking about, the person, the attribute, whatever, you're either part of the class or you're not. Again, that's the dummy variable part of it, right? But that's what you want to do. Just 1 or 0. That's all I need to know, right? Yep. So Ashish, you're definitely looking ahead there, where you're changing qualitative inputs to quantitative, like one-hot encoding or some other techniques. Yep. And we're going to talk about that a little bit. But yes, you're right. It's not always binary. There are times when you do need more than that. And yeah, I'll hit upon that a little bit, but really that's more of an advanced discussion for another day. But yeah, I'm on board with your statement there, Ashish. Okay, so let's go to the next slide. And this is kind of headed in that direction. Now, Hamad and Ashish, I love your comments because it's a good segue for this next slide here. Okay. What about classification with more than 2 outcomes, right? Because we've already agreed that logistic regression is for that binary output, right? It's the probability of belonging to a class, right? That's what we're going to get from those formulas we saw, right? We agreed that it's a proportionate formula. It's always going to be 0 to 1, but it's really just for 2 classes, right? Here's the probability of these independent variables resulting in being a member of the yes/no class, the true/false, the default, not default, cancer, no cancer, right? But there's plenty of times where you're going to need more than 2 outputs, right? So this is where the authors are putting forth LDA, linear discriminant analysis, right? That's their approach to it. So I want to switch over to the PDF. Give me a second to bring that up. So this is in chapter 4. And this is their linear regression side, or their logistic regression. But I want to skip ahead to their LDA portion because we've essentially already covered all of this, right? I've taken all of this text and I've shown you what I think is the most important, right? So that's multiple linear. They should be coming up here. There we go. So now this is where they talk about LDA 4.4 in version 1 of the R book of ISL, right? This is where they talk about having to use multiple classes and the theorems that they use for it. And I like this section of the chapter because they talk about a couple of really relevant things. One, this is one of their really first explanations of confusion matrices, right? This is where they start to introduce confusion matrices. They also start to introduce some of the charting that you're going to use. Not that you're going to show your stakeholders, but the charting that you use internally. So I think this is all really valuable stuff. And I'm kind of scrolling because there's another thing I want to show you here. Bear with me a second. Here. They also have a great explanation of the ROC curve. So I encourage you to read all of this. I encourage you to understand what an ROC curve is. It's one of the questions that I ask in my interviews. I want you to know, I want you in my interviews to give me a really solid theoretical explanation of the ROC curve. What does it show you? What are we talking about when we talk about an ROC curve? That's a question that I ask. If you want to work for me, you got to know the answer to that question. And again, here, really good explanation or a really good start to understand a confusion matrix. Super important. That's another question I ask. What is a confusion matrix? What does it tell you? Right? So I'm pointing this out. Yeah, and by the way, yeah, this is also good here. The errors and the type 1s, type 2 errors, and that's another question I ask. What is a type 1? What is a type 2? What is the difference? Right? Give me a real world example of those. So there's a lot of really good text in this LDA section, and I'm going to encourage you to look at it and look and study it on your own. But I'm not going to have a section on LDA because in practice, in the real world, you are most likely going to use other models for multi-class classification. This is kind of where deep learning starts to come into the equation. So Ashish, we know with your comment and Hamed's comment, right? This is where you start to talk about different encoding methods for those times when you're going to have qualitative inputs with more than binary classes, right? When you have to go beyond those dummy variables we talked about, right? When you start to talk about that, yes, LDA can be used for multiple categories, but in reality, you're probably going to use a neural network, right? For most of these classification problems like this, for multi-class, you're going to need a neural network or some form of deep learning, right? So that's why I didn't really invest the time in an LDA explanation, because from a practical perspective, there's probably other models that you're going to explore that are going to be superior to LDA in a lot of situations, right? So Rahul, the answer is you're most likely going to start with a neural network exploration. Because, and another reason I say that is because when you're talking about these multi-class problems, it's usually not just 3 or 4, right? You're usually talking about something where you have 10 classes or something like that, right? It's going to be something where you have a lot of classes to look at, and when you have that many classes, you're usually going to have a lot of data behind it. So you start using some deep learning approach. Or even, in some cases, you'd be using like an XGBoost approach, right? So, or something else like that, right? Jeremiah says, is it because it's easier to use deep learning than LDA? No, it just tends to be more effective because you're going to have more classes. When you're looking at multi-class categorization, it's rarely just going to be 3 classes, right? 4 classes. It's going to be like 10 classes, 15 classes. I've done models with up to like, I think 35 classes or 40 classes in one case that I can think of, right? So 40 classes means you're going to have a ton of data, and so it becomes a deep learning problem at that point. So just from my so again, just from, like I say, but in practice, right here in my notes, like as a practical perspective, right? You're gonna be saying, okay, let me start looking at some deep learning. Let me start bringing in some bigger models. Let me start going to a GPU instead of a CPU, right? I mean, it's kind of a step up, right? In all respects. So that's why I'm telling you guys, read the LDA section. There's great discussion in ROC curves on the confusion matrices, great explanations. But from a practical perspective, I don't want to invest more time in this because I just don't think it'll be worth the time here, given that you're mostly be going into deep learning techniques when you're really talking about multi-class approaches. So again, this is me curating the chapters, right? This is me saying, yeah, you're going to need that. Maybe you don't need this so much. So I'm thinking that LDA, you're going to be using other approaches instead. Okay. Rahul says, what kind of deep learning are we talking about? It depends, Rahul. It depends on the problem. It depends on how much data you have, how many independent variables you're going to have, right? I'm just saying that you most likely would not be using LDA, right? And again, we don't want to get caught up in saying, well, I'm always going to use a neural network. I'm always going to use a CNN or whatever the case may be, right? I'm not saying you should always be like that narrow. I'm just saying that this is where LDA is kind of put to the side and other approaches are explored because it most likely becomes a deep learning problem at that point. That's all I'm saying, okay? So I'm going to leave you guys with that because, LDA, is good, and it's good for study, academic stuff. But there's deep learning is usually where comes into the picture when you're talking about these big multi-class problems. All right? Yeah, Jeremiah, so neural network can be one of the ways, but it can be in any number of things, right? The point is that it probably won't be LDA. All right, so let's move on here, because now we can talk about the second model that's introduced, and it's K nearest neighbors, KNNs. And I'm also going to kick off by telling you to not confuse it with K-means. So I know a lot of you read the chapter ahead of time, and if you didn't, that's okay. But does anybody want to volunteer their understanding, their elevator pitch for what KNN is? And if you're feeling brave, tell me about K-means also, or pick one of those. Pick one, pick both, whatever you're comfortable with. Or maybe you're not comfortable at all. You can just sit back. That's okay. But does anybody want to volunteer to tell me about nearest neighbors or K-means? I'll give you guys a minute here on that. What do you guys think? Maybe we've taken a step up in the level of complexity here. That's why I'm getting less answers. Okay, Lakshmi volunteers. It is used for both classification and regression. Okay, Lakshmi. Patrick says KNN is using nearby points to test our points to assign a class. Yep. Yep, I'm on board with that. Anybody else or anybody want to try k-means? Explore the beauty of nature says KNN is classification, means an observation is likely to have similar values as values of its immediate neighbors. Okay, I like that explanation. Jeremiah says for KNN, if I am not wrong, we would have a test point which we try to observe which are the points that are nearest to the test points. I'm not sure if I get what you're trying to say there. Rahul says these are clustering approaches. KNN uses the distance between all nearest points, where K-means uses the mean distance, I guess. Ooh, Rahul, I love that you took a stab at K-means. I'm not sure if I'm on board with your K-means explanation. There's a key difference for K-means, though, right? So help me find that key difference. Oh, okay. Patrick already found it. And actually, it ties to Hamed's answer too. K-means is an unsupervised algorithm for clustering data in a natural way. That's exactly right. When you hear K-means, you should mostly be hearing unsupervised approaches. And Hamad says KNN is supervised machine learning model used to overcome the problems of classification and regression. Yeah, Hamad, that's a great answer. But yeah, both of you hit it right on the head. KNN, generally speaking, is a supervised approach. K-means is an unsupervised approach, right? So what Satya says K-means is based on the calculation of square mean of individual points, and a linear line is drawn with the lowest squared error. I don't know, chat. Is Satya right on that? I hope I'm understanding your explanation correctly. I'm not sure if I'm 100% with it, though. Tungamac, welcome to the chat. I don't think I've seen you before. Prediction based on nearest attributes from a set of data. Yeah. Yeah, nice answer. I like that answer a lot. That answer will work. Lakshmi says it uses Euclidean distance to measure the proximity between data points. Yeah. Yeah, in a way. Underneath the hood, it is doing that. Yeah. But yeah, you know, I want to come back and highlight Patrick's answer and Hamed's answer, because both of them are sharing some key points, right? KNN is supervised. It helps you overcome the problems of classification and regression because it is a way you can use for multiple classes, right? And then Patrick also talks about how K-means is unsupervised, and he also mentions the key of clustering, right? It's a clustering approach. Well, excuse me, both of these KNN are clustering approaches, and that's kind of what you should be hearing in your mind, that it's a clustering approach, right? Clustering is very key in a lot of problems, right? Because again, not everything has a quantitative output. You're going to have qualitative outputs also, right? So that's what KNN helps you with, right? She says K equals 3 as an example. We find the 3 nearest neighbor points to our test point, and then we categorize our test point. Yeah. So, by the way, I make a mention here too that unfortunately I'm not on board with the way the authors wrote this, because KNN is actually mentioned in chapter 2. It's only briefly referenced in chapter 3, even though they give you lab exercises in chapter 3, not chapter 2. So it's kind of out of sequence. It's a little messy, you know? So I will ask you to refer to chapter 2 for KNN. And this is one of the charts from chapter 2, and it's a good segue from all of the answers that we've had so far, right? Because this is showing KNN. This is showing clustering methods. So what you should be seeing is that both of these charts have the same dots, right? The dots are in the same locations, right? The difference is how many clusters you're using for your dots. So here we can see that the algorithm has determined 2 clusters, or excuse me, 2 categories, and then it has the different clusters of where it's putting each one of those members. On top of that, you can also see the correlation of members of each cluster to each other. So for example, let's hone in on this one here, this one here in the lower quadrant, lower left-hand side of this chart, you can see that it actually belongs to the blue class. But how close is it to the other ones? It's not, right? And that's why, even though it's part of the blue class, it actually sits in the orange class. And it sits just outside of the blue class. But it's also very far away from the other class members. Over here, you have two class members that are very close to one another. But then you also have this orange member that's still within the orange, but still kind of close to the blue, right? So it's like orange, but leaning blue. Or there's this one here that's literally on the border between the two. But it's still labeled as being part of the orange cluster. I'm highlighting this because, again, this is important for that business translation of how you will actually talk about these things to your business stakeholders, right? You're going to be talking about these things in terms of why these clusters share, these items, these members share the same attributes. Why are they orange? And why are they so close to each other? Very, very important skill as far as being able to translate your results. So, I couldn't find a chart that's a good example of this, right? But let's pretend that right here in this corner, I have a member, and we'll say for the moment, it's neither orange nor blue. We'll just say that it's a purple color, and it sits right here in this corner. It sits really far from the blue clusters, and even though it's in the orange cluster, it sits really far from any of the orange members. What's the name for that? What would you call that? Or why is it important to think about those types of members that sit? Why is it important to think about a member that sits in a corner like that? I'll give you guys a minute to think about that. Ooh, if you guys are fast on this one. Fast, fast, fast. Explore the beauty of nature, you got it. It's an outlier. Right? That's why you want to take the time sometimes to plot this out. Or to think about those values, right? Because you're going to assign values too. To think about those values. But yeah, that's an outlier, right? That's super key to be able to acknowledge in your items, right? To be able to say, yeah, I was able to plot this, but it sits way off in the corner. It's not near any other members. It's an outlier. Or in some cases, and I want to come back to, Lakshmi, it can also be an anomaly. Sure, it can be anomalous data. But keep in mind, though, in a lot of these cases, we're talking about qualitative data, right? Qualitative data is often not always an anomaly, right? So, coming back to Servan's question, another way to also look at this for your outliers, or for these items that sit in the corner, nowhere near any of the other members, you know what else it means? It might indicate a need for a new class. Maybe you need more than the classes that you have. So yeah, it's an outlier, but what are you going to do about it? Well, maybe you need to introduce a new class. So Servan, I like your question. Hey Dennis, any real-time example from your experience? Yeah. I'll give you a really interesting example that I actually created this project and we actually ran with it. I love this project. So I want to keep things generic because I want to protect my clients. But a lot of clients that you're going to run into, a lot of projects, are going to be concerned with how you are addressing policies and laws that are out there, right? So you want to make sure that you're always addressing policies and laws, because the policies and laws that you don't cover are what are known as an emerging risk, right? That's the business term for it. Because if you can say these are the 10 laws, and this is how I'm covering those 10 laws, anything that falls outside of those laws is a risk to you, right? Because that's something where you could be potentially breaking the law. So I was approached by a client that wanted to identify emerging risks. And a clustering approach, very similar to what you're seeing on your screen, it is what we created for them, right? Because if you want to think about this as another way, guys, another way I think about this, and the way I explain it to my clients, is that this is a big filter, right? A clustering approach is a big filter. I'm going to create a really solid model that can take your data and filter it into these categories really quickly. It's almost like one of those, in the US we call it like a colander or a sieve, something where like you would drain your spaghetti, right? You put your spaghetti in the top and all the water comes out, right? So it's a big filter, a big sieve in that way, right? So if you have that and you have everything being categorized, what's left in the bowl? What didn't get categorized, or at least strongly categorized? If you do it right, the stuff that's left over in the bowl, the stuff that didn't get filtered, that's your emerging risk, right? So it's almost like you're creating a filter to see what gets omitted, right? Because that stuff that gets omitted could be an emerging risk in that scenario. This is the item where you couldn't classify a law to it or a policy to it. Or rather, it's the other way. This is the law that you couldn't classify a policy to it. So because you don't have policy to cover that law, that's an emerging risk, right? So that's how I mostly use these clusterings, where it's just like a big filter for you to dump a bunch of stuff into. It all comes out as it should, and then you look for what's left over. And that's, and then that's the business value, right? What's left over are the things that you should be like, well, we need to take a look at this, right? That's how you identify what you need to take a look at. So Sravan, I hope that helps you. Because again, I can't give details with my clients and all that, but that's an example of that, where you can use it as a big filter to find out other things that do classify properly, and those are okay. But what doesn't classify properly? What kind of sits out there on the outside? What did get classified, but is really far from the centroid or really far from the other members? Is that a need for a new class, right? Okay, Sravan says that's awesome. Thanks. Okay, cool. I'm glad that helped. So Jeremiah says, how do you determine whether it's just an outlier or whether you should include a new class? That's the experimentation, right? That's the experimentation of data science. You should be trying multiple classes. You should be trying what those different scenarios look like. What does it look like for 3 classes, 4 classes, 5 classes, 20 classes? There's a lot of value in that. Yeah, Patrick, thanks for the answer. Hamed says, how a single data point makes a new class. Do you mean how you put it into a new class? Or what do you mean, Hamad? Let me know what you mean there. Nazish says, so an outlier won't get filtered, right? No, it will get filtered. It will get categorized, right? The filtering comes in you saying, well, show me the ones that look like outliers. Show me the ones that aren't close to the centroid, that aren't close to other members of the same category. That's the filtering I'm talking about. And that's more of a straight programming exercise, right? That's not data science. That's getting more into the interpretive side. Because again, those are the ones that should raise concern, not just for you, but for the business, right? Because why is it an outlier? Because in my example, right, that it would be an outlier because you don't have a policy to help you with a law that exists. So that's how you kind of, rationalize that out. Okay? All right, so are there any more questions? Because otherwise we are going to be going into the lab side of this, because my next slide is the framework example. But any other questions there before we move on? Yeah, Jeremiah, you're asking the same question twice. It's the experimentation. Generally, you would start with the number of labels that you have, the number of classes that you have. Right? That's a starting point, but you can experiment. You can experiment with it beyond that. All right. So we're going to move on, and we're going to start looking at the lab, and we're going to start, using ChatGPT to help us. Sravan says, Dennis, you are making me love DS more and more. Well, good. I'm glad. That's kind of the reason why I started this whole content creation effort. And I also want you to love it in a very professional way, not just the other junk that you find on YouTube. But yeah, so thanks for that feedback. All right, so let's look at the next slide. So here's the framework, right? What is the result that we are optimizing for? That's always a question we're asking of ourselves. What does the code look like, right? And again, we're not being level 1 analysts, we're being level 2 data scientists, and we're prompting an LLM for assistance. And we are going to be code editors, not code writers. We're going to establish a professional level development environment. We're going to find an appropriate data set. We're going to create a logistic regression model. That'll be one exercise. And then we're going to create a KNN model. And then we're going to look at we're going to look at the metrics for all of these models. Because really, this is kind of like the basic modeling aspect of being a data scientist. Okay? All right, so this is where we leave the deck. And we're going to go to working in Visual Studio Code. And we are then going to also work in Terminal. So I think that this VS Code will be big enough. If not, let me know. And then I'm also going to be using a terminal window. So I won't use the same trick question as last time. But if you think that we're going to sit here and work in a notebook, that's wrong. Professional data science development is rarely done in a notebook. You're going to hit a lot of ceilings and a lot of needs in a corporate enterprise distributed environment where a notebook simply is not going to work for you. So we are working in a professional way with a dedicated IDE, right? We're using VS Code. You can use something else, right? I mean, I've experimented with a couple other ones. You really choose whatever you'd like. I just happen to be using VS Code. And then we're also going to be calling everything from a terminal. And you can see here, I already have a dedicated environment, a dedicated Conda environment where I'm running all of my code, right? Because you always want to be running in your own isolated environment. And sometimes you want to have an environment for your development, for your testing, and for your deployment, right? But that's one of the things I want to make sure I also emphasize, that professional data science, professional development is not done in a notebook. It's done in a dedicated IDE and in the terminal. All right? I mean, I know that rattles a lot of cages because a lot of people have never even programmed outside of a notebook. But if you want to work in a professional environment with a professional approach, this is how we're going to do it. All right. So we're going to start by establishing our file that we're going to need. And let's call this logistic regression. So that's our blank screen, but we're not starting from a blank screen. We're going to be using ChatGPT. So let me bring that up. And again, if you need me to zoom anything, let me know. Okay, So these are the frameworks it knows. Scikit-learn, stats models, Keras, TensorFlow, PyTorch. PyTorch is for people who don't love themselves. And yeah, so I think this is reasonable code to start from. All right, so now let's continue our prompting. Let me make sure I bring up OBS also so I can see your questions. Okay, so we're going to tell it we want to use scikit-learn. And then it's important for us to see our metrics, right? Because we're data scientists, right? So we always want to measure our metrics and see how it works. Just a regression model. All right, let's see what it gives us. We're going to do an install of scikit-learn, which already exists in our environment. That's pretty standard. It's going to use NumPy. It's going to use train test splitting. It's going to use a learning data set. All right, what do you guys think? Can you guys see that okay, or should I bring that to VS Code? Yeah, this looks really good, actually. Explore the beauty of nature. Don't take it seriously, man. It's just lightening the conversation. Relax. You can use PyTorch all you want. All right, what do you guys think about this code? Sorry, you guys are too serious. I just like picking on PyTorch and Java. It's just for fun, guys. Relax. What do you guys think? Line 9 here is jumping out at me. Excuse me. What do you guys think? Does this code look reasonable to everybody? Or anything else jumping out at somebody? What is this telling you guys? Anybody? Okay, so Patrick says it seems good. It does seem good, right? Like I think this code is reasonable. But again, you know, we're not being blind here. You know, we have to use our own skills. Because remember, guys, we also saw the ChatGPT make a very basic mistake last week, so we got to be on our toes here. So what is special about line 9? What do you guys think? Okay, Hamad said also looks good. All right. Well, look, the answer is that line 9 jumps out at me. Like, that's the first thing I noticed. 1, it's telling us what our sample size is. 2, it's telling us n features equals 20. That means it's going to use 20 different features, 20 different x's, right? Coming back to our formulas. It's also telling us classes equals 2, which is what we would expect, right? For logistic regression. And then it sets a random seed, you know, which is common, right? But those things you should be looking at, right? Because ChatGPT could have made a mistake, right? It could have said n features or n classes equals 6. Are we doing logistic regression at that point? No, right? That's not logistic regression. right? So these are the types of things that we again, as editors, should be looking at. This will become our new work, right? We're not going to be starting from a blank screen, but we sure do need to verify what it tells us, right? Yeah, Patrick. So it is our data set creation, Patrick. But there's a lot of really important things in here, right? Because it's telling us what ChatGPT chose for us for that data set, right? So really important. Same thing here. Here we can see that ChatGPT has chosen our test size for our test train split, right? Our train test split, right? It's telling us that it's going to train on 20% of that data set, 20% of the 1,000 samples, right? Is that reasonable? Yeah. Are there times we want to adjust that number? Sure. Depending on the data we want to use. But these are the things that like your trained data scientist eye should be looking at, and should be saying, "Oh yeah, wait a minute, that does look good," or "No, whoa, wait a minute, what's going on there?" Okay, see, so Hamad Javed says train test should be 70-30, I think. Yeah, maybe. There's times when you're going to want to adjust that. I mean, we haven't run this particular code, so I can't tell that. But yeah, Hamad's right on that. There are times you're going to want to adjust that. But again, my point here is not to stress the methodology. It's more about, hey, we didn't write this code, so we still need to be editors of it. We still need to kind of take a critical eye and say, yeah, that looks good, or no, that doesn't look so good. I think ChatGPT made a mistake here, right? So I want to kind of stress that to you guys, because it's super important to be able to understand that, and that we're not just sitting back, right? We still need to be trained. We still need to be a pretty smart data scientist. But we still need to kind of, go for it, right? As she says, surprisingly, ChatGPT gave me almost the same code in the same random state. I am glad. Assuming it's correct, right? We haven't run it yet. But yeah, generally speaking, that's a good thing, right? But we haven't run it yet, right? So I love the fact also, another thing that caught my eye, guys, we're going to run this code shortly, but another thing that caught my eye is that it also gave us the accuracy like we asked. It also gave us a classification report, and it also gave us a confusion matrix. That's a very reasonable amount of metrics for us to use. So I'm really happy that ChatGPT did that. We only asked for accuracy, but it knows what we're asking for, and we should ask for a classification report and a confusion matrix. I was planning to iterate that, right? To say, okay, yeah, that's good, but then give me this, and we can still iterate through this. But ChatGPT kind of anticipated our needs and gave us the classification matrix and the classification report and the confusion matrix. So I think that this code looks reasonable enough for us to run. But yeah, let's try it. So we're going to go to our terminal. And what do we call it? Logistic regression. Okay, so now we're going to verify that the file is there. And it is. We have two files. I see my logistic regression. So now we're going to run Python regression.py, and let's see what it gives us. Okay. So I hope that's clear on your end, guys. Let me know if it's not. But it's giving me an accuracy of 85.5, F1 score of 0.85 for the 0 category, and 0.86 for the 1. The support column, right? That sums up to 200, which we shouldn't be surprised at. And everything else looks pretty reasonable. It's giving us a confusion matrix. I love how it laid it out. So what do you guys think? Give me your feedback on this. What do you guys think of these numbers? Anything jumping out at anybody? What would you be looking at to make sure that ChatGPT gave you valid code? There's one item that's jumping out at me. Yeah, there's one item that's jumping out at me on this chart. As far as, me verifying that ChatGPT is giving us a reasonable approach here. What do you guys think? If you just want to give me a looks good to me in the chat, that's perfectly acceptable. But there is, some things that are jumping out at me. One thing that's jumping out at me, I should say. Wow, we're almost at 2 hours, guys. Jeez, thanks for hanging in there with me. Wow. What do you guys think? Anything jumping out at the answers? Okay, Rahul, I appreciate the honesty, my friend. To be honest, I don't know how to interpret this, I'm afraid. Rahul, that's perfectly okay, my friend. It's important for us as data scientists to recognize our limitations, right? To be able to know when you can speak intelligently on something and when you can't. So Rahul, I appreciate the honesty. Totally okay. Patrick says all the numbers look reasonable. Michael says same. I don't know. Michael, I don't know if you're agreeing with Patrick or Rahul. It's kind of polarized there. Bala says macro average for precision and recall. What about them? Is something not sitting right with you there? Let me know. A lot of 0.85 by Michael. Okay. That's a good observation. Patrick says, do we usually break out precision and recall for each class? Yeah, you do. Yeah, even in the multi-class, you would do that. Yeah, that's standard. Yeah, see, Michael, Michael, you got me super curious on whether you were agreeing with Patrick or Rahul. So, Michael, are you good with this, or do you need a little help? Let me know. She says my code gave me the same numbers. Okay. Ashish, do you know why that is? I know why. I fully expected that. So for extra credit, let me know if you know why it gave you the same numbers. But I fully anticipated that. I'm not surprised at that by all. Michael says with Rahul, okay, so Michael's being honest. He doesn't know how to interpret this. That's okay. Okay, so yeah, so a couple things jump out at me here. One thing we're going to start off on a basic level. The first thing that jumped out at me is the support numbers, because it's basically telling you how many are found within each of those classes. And what I'm looking for is that I want to see a balance between the two classes. So when you are doing categorical problems, classification problems like this, you want to make sure that your training data has enough samples that represent each of those classes, right? It's what's known as balancing. So when you hear about a balanced data set or a balanced training set, that's what you're referring to. So if you have two classes, or you want to make sure that you have roughly the same number of examples from each class in your training set. So that's what the support number is telling you. And this is a reasonably balanced set, because it's telling you how many are members of each class, right? So this is telling you that of the 0 class, the null class, it had 93 members, and it used 107 members of the positive class in the training. Or excuse me, in the test, right? So that's a very valuable piece of knowledge to know, really to kind of validate your model, right? Because if these numbers were unbalanced, like it was like 15 from the null class and 185 from the positive class, that's a very unbalanced set. I wouldn't put a lot of faith in that model. Like no matter what the other numbers say, the entire model is probably not useful, right? You should probably throw that one away. But this one is reasonably balanced, so we can have a pretty good level of confidence in the model. So that's the first thing I'm looking for, right? I want to make sure that I'm using a balanced data set, right? The other thing that jumps out at me is that we can look at these precision and recall numbers. And by the way, the F1 score is an amalgamation of all those numbers, right? So you can kind of use that as your single value if you want to just look at something to evaluate. These numbers tell me that it's a reasonable model. These are reasonable results. It's certainly reasonable for your initial model, which can then be like your baseline model that you compare against, right? Because we should always have a baseline model. So this is reasonable, right? But that all depends on the business needs, right? Let's say that I want you guys to clear your mind, right? And I tell you that this model is a model that predicts whether somebody will default on a loan or not. And this is telling you overall at this we'll focus on the accuracy number. The accuracy value is 85.5. Your F1 scores are in that same range, so that means you can take a pretty good confidence interval or confidence feeling in that accuracy number, right? Do you think this is reasonable for a model that is going to make loan decisions? So Hamad is asking a similar question. If accuracy is more than 0.7, then model is all right. So again, let's clear our minds. And I'm telling you that this is for a bank. This is for loan decisions. And it has an accuracy of 85.5. How do you guys feel about that? So tell me how you guys feel about that. What's your take on that? 85% accuracy for a model to make loan decisions. Tell me how you guys feel about it. So I am Agnes. The goal of this model in our example right now is that it makes loan decisions for a yes, no of getting a loan. How do you guys feel about that? I'll give you guys another 30 seconds in the chat. Let me know. You feeling pretty good about these results? Okay, so Hamad said for me it's more than reasonable. Okay. Anybody else? Just give me a feeling on it. You don't have to give me a rationale. Give you guys another few seconds here. Ashish says good enough. Maybe good enough. Okay. Anybody else? Patrick says 15% of loans will default. Not good. No, Patrick, that's not what this is telling you. This is telling you the accuracy of the model, right? That's what it's telling you. The results itself is more in the precision and the recall, right? Michael says good enough, but I think it depends on the bank. Okay. Explore the Beauty says this is okay. Okay. Moriah, welcome. I don't think I've seen you participate before. Welcome to the chat. It says in between may be good to good enough. Okay. Okay. So let's stop right there, right? Now, clear your mind, and I tell you that this model is a model that's inside a fully self-driving vehicle, and this is the yes-no on whether to press the brakes or not and stop. Now what do you guys think? Is 85% accuracy good enough? Give me your answer to that. Forget the loans, forget the banks. Now this is a model that's inside a full self-driving vehicle, a Tesla or whatever. And this is the model that decides yes, no, press the brakes. What do you guys think? How are you feeling about 85% then? Okay. See, Karthi says no. Moriah says not good. Jeremiah, no. Ashish, no. Yep, that's exactly right, guys. Karthi came back and corrected themselves on saying hell no because they wanted to make sure that we got his answer. Okay, Karthi, message received. Hell no, we got it. Okay, good. You guys are getting it. What's the lesson here, right? The model looks reasonable, but what's your real world application? How are you using this model? How is the business using this model? Again, guys, this is the below average data scientist to the great data scientist, right? You always have to keep the business part in mind, right? This is what I want to impress upon you, right? That's the lesson, right? That's my Yoda Jedi whatever. I'm not a big Star Wars fan, but you now understand the lesson. All right? We as data scientists cannot live in numbers alone. You have to understand the real world impact of what we're working on. Is this model reasonable? Maybe not. What are we using it for? Where are we going to use it? How are we going to use it? How fast does it reply? Think about that. A model, just even if you got good accuracy, maybe it's too slow. Maybe the model doesn't work fast enough for you to press the brakes in time, right? You got to take this all into account. You got to remember these things, right? You got to know what the business approach is. Nobody in the real world of data science, nobody is giving you a paycheck to think just about numbers or they're asking you to think about business impact. That's how you earn a living in data science. Okay, guys? So as she says, thanks for the example, Dennis. I love this. Good. I'm glad you guys are getting it, right? Because remember, I'm not here to be a college professor. I'm here to tell you about the real world, right? So that's my addition to the ISL book, to everything we're talking about, right? So keep that in mind, guys. All right? So you guys are getting it, right? But that's what I wanted to get across to you guys. All right, let's move on. I'm ready for KNN. Who's ready for KNN? Okay, so one thing we're going to do with our chats, and one of the things I have found very strong about ChatGPT is that we can ask it to remember different pieces of code, right? So let's make sure we do that. All right. So see, ChatGPT has now saved it for us because we're going to come back to this model. I want to talk about one more thing at the end. Guys, we are past the 2-hour mark. I love this. Thanks so much for the participation. Thanks for hanging in there with me. Some of you have been with me online from the beginning, so props to you guys. Okay. So all right, let's see what it has for KNN. KNN is going to give us a classification. All right. It's giving us basically the same code, but it wants to use the classifier with neighbors equals 5. So I'm not sure if I'm on board with that. What do you guys think? I'm going to bring this over to VS Code so you guys can see it a little better. But I'm not sure if I'm on board with this. So we're going to call this knn.py. What do you guys think? I don't know if I'm on board with this because of the classes. If you guys notice, this is basically the same code as before, but it still wants to use k equals 5. I think that this would give us not so great results because there's only 2 classes, but it's asking for 5 clusters. What do you guys think? And by the way, you guys are asking really good questions in the chat. I'm going to come back to them. Meta, I want to come back to your question. Hamad, I want to come back to your question. Really good questions. So remind me at the end if I don't come back to them. You know, guys, I'm not on board with the number of classes. And I've seen ChatGPT make errors before and on other stuff I work with it. Weirdly enough, if you ask it to review its own code, it will make changes. So I want to do that. And it corrects itself. Or at least it says it's corrected itself. Change n classes if needed. Okay. That's weird. The only correction it did is it added this comment here. I want to see the rationale it gives me for this. All right, what do you guys think? Is that a reasonable rationale? It just doesn't seem right to me that it's telling us that we can use 5 models or 5 clusters for the neighbors when we know there's only 2 classes. What do you guys think? Is it asking for 5 clusters or using 5 neighbors to assign a class? Yeah. That's true. I could be misinterpreting the code. We can increase the number of classes. Yes, we can, right? And that's the first answer it gave us, right? It said that we can adjust the n classes parameter. The knn method requires selection of k, the number of neighbors, not to be confused with the number of classes in the earlier section of this chapter. Is that pulling from the book, Patrick? Okay, he's pulling from ISLR. It seems like ChatGPT will be assuming it's binary. But it's telling us that it doesn't have to be binary if we don't want it to, right? It said that we can adjust it. Okay. So Patrick, thanks for that quote. Yeah, I guess I'm tripping over my own shoelaces here. But let's go ahead and try it then. So that means we can go back to our terminal. Python. Okay. So our accuracy is a little bit different, but we're also using presumably different. Well, I guess no, it's going to be the exact same data. So it's the same data, right? And we can verify that because we can look at the support numbers, right? Same data. But you can see that the results we're getting are different. And look at our F1 scores. Our F1 scores have dropped considerably. So what do you guys think of these results? What do you guys think? Give you another minute here to think about in the chat. It feels like there is a room for improvement here, yeah? Yep, Ashish says accuracy is slightly lower. Yep, it is. Michael says not good. Did I change k equals 2? No, Patrick, I did not. I kept it at 5. We kept k at 5 and number of classes at 2. Personally, I think that's going to be a big part of that, right? A big cause of that. So there's a couple ways I want to go about this. Yeah, I'm trying to think about the best way to go about this. Let me go back here. And let's hit on Patrick's earlier point about how neighbors is something that we can modify, right? As Patrick pointed out here, the KNN method requires a selection of k, the number of neighbors. So let's pick a different number of neighbors. What if we went down to... No, let's increase it, actually. All right, what do you guys think? Before we run this, give me a 1 or a 0 in the chat. Do you think... Give me a 1 if you think that our results are going to improve. Give me a 0 if you don't think it's going to improve. It's going to stay the same or go lower. What do you think? Changing the number of neighbors, what is that going to do? Because remember, as we said, what it does is it takes in the other points that are close to it and creates those clusters, right? And makes those decisions on where it belongs, right? So here you're using more of those neighbors. So what do you guys think? Is it going to improve? Give me a 1 if it's going to improve, a 0 if you think it's going to be the same or lower. Okay, Rahul and Patrick are both on improve. So is Ashish. So is Lakshmi. Yeah, and I generally agree with that. We should see an improvement here, right? Are there any other concerns that we should have now? Can us changing this to 8 have any other impacts that we should consider? I can think of one. Give you guys a couple seconds to think about that. In the meantime, I'm going to run it, but I want you guys to think about that. Are there any other impacts we should consider given that we now change to 8? So these are our results using 8, right? Ah, Patrick hits on a good one. More neighbors equals more computation. That's exactly right. What else could it mean? Does it mean more data? What does that mean for our 0.2 for our trained test split? Earlier, some of you thought that the trained test split should be more like 70-30. Yeah, and Jeremiah's right. It's not any better. So now, I want to go back, and I want to increase my samples. And now, using the earlier advice, I can't remember who it was, but somebody suggested a 70-30 split. I want to do this. Right? Let's run this version. Still 8 neighbors, right? Now what do we think? It's gone up, right? Our accuracy has improved. It's gone up by almost 2 percentage points on the accuracy. And our F1 scores, look at our F1 scores now. Our F1 scores are much more reasonable. So now, what if we go back, or what if we pick something in between? We went from 5 to 8. Let's pick a 6. You know, just increase the neighbors a little bit, not as much as 8. Now what? $81.3, so it dropped. So there's a big difference between using 8 neighbors, right, which is 82.4, versus just 6 neighbors, right? Let's see what this looks like. Now we're pushing it to 12. And 84 is an improvement, right? That's an improvement over 8. What was 8 at? 8 was 82.4, yep. And now we are 84.07. What do you guys think now? 84.07, now we're approaching what we were getting before with the logistic regression model, right? What do you guys think? Let me know what you guys think in the chat. The chat has slowed down. I'm guessing you guys are thoroughly confused now. Is anybody out there confused and wants to admit it? Lakshmi says increase the accuracy but increasing the neighbors. Yep, we sure did. More data is more better. There's some interplay between a number of neighbors and available volume of training data. Yeah, there's a correlation there, Patrick. But we are causing that correlation because we are asking the model to use more neighbors, right? So we are the cause of that correlation. But Lakshmi's observation is valid, right? It increased the accuracy, but increasing the neighbors. And we should expect that, right? Because we're giving the model more data to work with for each of the individual data points, right? So here's where I want to go with this. And this is going to be a little bit of a new concept, but something super, super important for you guys. This number of neighbors, right? And this conversation that we're having. We started at 5, we went to 8. No, let's bring it down to 6. Well, what about 12? That conversation, that's the experimentation of data science. This is where the experimentation of data science begins. So when I tell you guys that, data science is a scientist, I think of myself as a scientist first, we should be applying the scientific method. This is where all of that begins. So the takeaway here is something known as a hyperparameter. right? That's what you're talking about when we're adjusting the neighbors. Adjusting the neighbors is an example of hyperparameter tuning. So that's where you would begin your experimentation. What happens if we just use 2 neighbors, 3, 4, 5, 27 neighbors, right? Where is like that diminishing returns, or where does the improvement happen the most? This is where the experimentation of data science begins. So you would want to do some what's referred to as hyperparameter tuning to figure that out. This is an example of that hyperparameter tuning. And then you might want to make adjustments to say, well, if I'm going to increase on my number of neighbors, then I need more data, right? So now it's on you to go out to the business and say, hey, I need 10,000 more records. Or maybe you need to examine how balanced that data set is, because if it's an unbalanced data set, you have to fix that, right? Very few things are going to help you there from an experimentation perspective, right? So these are the things that you're kind of being slowly introduced to. So I'm showing you a manual example of how to conduct that hyperparameter tuning. But there's ways for you to do it via code, right? You're going to want to Google about grid searches, right? Because grid searches is essentially what you would use. Or in some cases, for something like this, you could do it by yourself in code, right? You can do it by yourself, doing just doing a loop, right? And trying different versions of the model. This is going to be my version 1, my version 2, my version 3. Okay, what did I change from model to model? You want to minimize the number of changes you're doing in each model, okay? So I want you guys to think about it in those terms, that this is where the experimentation of data science begins. All right, there's one more thing I want to cover before I leave you guys, because I think we should be looking to wrap up the session. We're hitting 2.5 hours, guys. Good for you guys for hanging in there with me. There's one more thing I want to cover, and again, we are not code writers, we are editors. So I want you to, we're going to go back to our chat GPT. So use version 1 and so here's one more thing I want to leave you guys with, and I meant to show this to you guys last week, but we just ran out of time. But I want to copy this code, and we're going to go back to Visual Studio. We're going to go to our, let's create a new file. Logistic. Here's another thing where I'm going to rattle some cages. But you guys need to get used to this, because again, we are professional data scientists in here, right? So professional data scientists write programs, not scripts. So this is a script. This is a pretty straightforward script with sequential programming, right? But if you want to get out there in the real world and you really want to, if you really want to impress on a code test, or you really want to impress somebody on your first day, because you landed a job and you want to show that you work in a professional environment, this is a type of code I want to encourage all of you to start with or start working on, right? You should have an entry point. You should be pointing to a main method. The main method sits here, and it's basically just using the same code we did before, but in a way that's broken out by methods. You have your imports at the top, you have the methods that you're going to need, and then you have the main, right? So in main, you're loading your data, right? So that means you're calling your load data method, which is really the same as before, right? Same lines, but it's a much more organized, much more reusable way, and it's also commented, right? ChatGPT added the comments for us. But this is how you lay out professional code. And I have a template, and I want to show you one more thing that ChatGPT does not add, is you also want to add a template header, or excuse me, a file header that is always sits at the very top of all of the code that you write. Okay? So you're going to describe what the file does. In your old school files, your old school guys, they also include the name of the file at the top. That's something that's kind of fallen out of practice, but you are going to come across some files that do that. But you always describe what your code does and any inputs and outputs that you need. And then you always write a copyright. Your employer or your client usually owns the copyright. So that's me. I have my own LLC. And then you always list yourself as the prepared by person or the programmed by person, because in the real world, you do not own the copyright to your code. That's called your stock and trade, right? The stock and trade is that you wrote the code, but they're paying you for it, so the company owns the code. You never put a copyright of yourself. And then that's where you start the rest of your Python. So if we run this Python will run the same as it did before, right? It's not going to be any different, but it's much more readable, and it kind of adds that professional polish to your code. All right? So I want to leave that with you. I meant to leave that with you last time, but I want to make sure that you are also just taking the time to do that extra polish to your code. Okay? So if you have any questions on that, let me know. I might put this file up on our Discord so that you guys can see an example of it. But start working away from notebooks, start working away from scripts, and start thinking more about programs where you're taking the time to create your own methods. And then the next iteration of this is to create your own classes, right? In theory, this could be its own class, and it should be its own class, right? We could easily rewrite this to be its own class. But these are the types of things that I want you to think about when you're getting out from the to the real world. Okay. All right, guys. So going back to the deck, I've hit on all the lab items that I wanted to do. We created a logistic regression. We created a KNN model. Okay. Self-study. We only did single. Well, actually, no. I guess we did do multiple features, right? So, what does it look like when you play with the features? Can features be a hyperparameter that we talked about? Can features be a hyperparameter that you tune? Yeah, it can be, right? We were using synthetic data. So now, can you replicate these results with real-world data? Go out and find a real-world data set. So, for example, you're probably going to have problems with balancing, right? How do you overcome that? And then third, can you replicate these same results with another framework, right? If we go to the beginning, or I guess, you know what, somebody was butthurt in the chat when I said don't use PyTorch. So go ahead and use PyTorch. What does this look like in PyTorch? Right? Go use another framework and recreate the same results. Right? So those are all things for you to think about as far as your self-study. All right, guys. So I'm gonna look at the chat questions because I think we had some good ones. Last call for questions. We've gone for 2.5 hours. So last call for questions. But I'm gonna hit some of these questions. I think you guys are asking some really good ones. So let me go back to my broad view. All right. We had some really good questions. Yeah. So Meta asked a great question. How does the team check its applicability that it is actually satisfying business metrics requirements? You don't know. You don't know the answer, and that's why you should be involving the business. The business ultimately makes those decisions. And they know their data best, and they know the goal that they're trying to achieve. The best that we can do as a team is to present them with options. And to say, here, we did our modeling, and here is the 4 options you can choose from. And if you choose this option, these are the trade-offs. If you choose that option, these are the trade-offs, right? Or the business might tell you, yeah, show me 5 different models, but only if there's 75% accuracy above or not, right? They might set that threshold for you, but then you can show them different options above that threshold. So that's another way to do it. But the key takeaway here, Meta, is don't make those decisions on your own. Your stakeholders know that best, right? We conduct the experiments, we report on those experiments, we report on what the impact is of each of those selections, and then they choose from there, right? So that's the key takeaway you should be thinking about, that we as a data science team shouldn't be in charge of making those decisions. The business should ultimately make those decisions. All right, let me make sure I go to some of the other ones. Yeah, Hamad says, considering your autonomous car example, it's horrible. Yeah, it can be absolutely horrible depending on the application. So, yeah, so when somebody says, I got 85% accuracy, great, maybe, but what are you using it for? How, is it effective for the real world application that you're going to take that to, right? See, again, this is one of the reasons why I get so disappointed in all of the people that are obsessed with math and data science. Data science is not a math exercise. It's a real world applied exercise, right? You can't just be siloed into your numbers and formulas, right? That's not data science. Data science has real world applications. Data science has real world implications in the effects it has on people. So yeah, in a decision for a car to stop or not, that's a terrible accuracy rate, right? It doesn't matter how beautiful the formula was to get there, and this is some great formula that I moved into code. Who cares if it can kill somebody, right? So don't get caught up in everybody else talking about the math and you got to know linear algebra. No, it's an applied science. Okay. Lakshmi says also 730 split improved, I guess. Yes, it did improve, but we should have expected that, right? We should have expected that because you're giving more data available for the model to learn from, right? Or to test on, right? And it's going to make those adjustments based on that. So yeah, it did help. Some would expect it, but you also don't want to get too crazy with that tuning, right? Because then you could be running into issues where it's more of a bias that's in your training data. So you want to be careful with it. It's a careful balance. But again, that's the experimentation of being a data scientist. Okay? Okay, we got a Stack Overflow question. Patrick says stop off. Yeah, thanks a lot to Patrick for all his moderation and all his work. Okay, Lakshmi says we can also use feature selection for improving model performance. What is your view on this? Absolutely you can, right? You can absolutely do that. Again, it's tempting to think about it as a hyperparameter, but it's really not. It's more about how you're setting up your entire experiments, your entire modeling to begin with. Because when you're talking about feature selection, you're also talking about feature engineering, right? What are some of the features that are there that you can modify into other features? What are some of the other data sets you can bring in, right? Answers aren't always within your data set. You might need some external data, what's known as enrichment, right? To help you with that, right? So yeah, Lakshmi, I love your thinking. You're on the right track with that. Because there are times when you are going to have to bring in other data, or maybe there's a time where you're doing all this testing and you can't get beyond that 85% that we saw, right? Because we didn't see anything above 85. But now you're saying, well, wait a minute, let me bring in this other data set. Let me bring in this macro financial data. Let me bring in this weather data. Let me bring in, other sales information that that was just made available to us. Yeah, so you're on the right track, Lakshmi. I love your thinking. That's exactly what you want to be doing at all times, right? That's you using your creative data scientist mind. So good track on that. Ashish, thank you, Dennis, for that extra tip, especially the note. Thanks again for the hard work. Yeah, you're welcome, Ashish. And I'm trying to show you guys in a professional way, right? If I'm contributing to the world of data science, I want to create professional data scientists, right? So I'm teaching in the same way I teach people that have worked for me over the years. And I think I'm teaching you stuff that nobody else out there is talking about, right? Because they haven't really worked in the real world. I mean, most of your data science people on the web haven't really worked in the real world. They just haven't. So yeah, so I'm showing you guys that. Explore the beauty of nature. Thank you for the tip. How does this compare with OOP? Yeah, great question. Love the question. Breaking out your code like this. Let me go back to that. Breaking out your code like this with a main entry point and your main methods, this is the start to OOP. The next iteration, as I mentioned earlier, is to take all of these others, these supporting methods, and create a class out of them. you can absolutely do that, right? And creating classes is your start to object-oriented programming, right? It's more reusable, it can be consumed in many different ways, so on and so on, right? So yeah, great question. And this is where it starts. So explore the beauty. If you want to kind of take that as your next step, that would be a next step. Take this code here and break it out into a class. That's a great step towards OOP. And if you send me that, or you create that in a coding test that somebody gives you, that's like, you know what you're doing, right? Like you're adding that extra professionalism to your code when you start writing like this, and then you take it to a class and you consume, and then you instantiate the class properly and you use the class like you're showing some really good stuff, right? That's a strong application if you're still trying to, land a data science job, okay? Synthetic data eliminates EDA? No. It just so happens we didn't do EDA for this particular exercise, right? But no, it's no EDA. You're always doing EDA. Thanks so much, Dennis. Next Sunday we'll be covering Chapter 5. Yes, we will, my friend. And great job in participating today, Rahul. You gave some great answers. But yeah, Chapter 5 is next Sunday. That's exactly right. Jeremiah says good night. Okay, good night, Jeremiah. And Neruth Mani joined late but still gained great value with content. Thank you. Well, thank you so much. Appreciate that feedback. Feel free to go to the replays. As soon as I finish, the replay is posted on YouTube. So if you want to catch the first half, go and see it there. We must optimize skewed data always. This example, it happened that the data was very balanced, right? But it's not always going to be that way, especially in real world data. So I agree with you, Hamad. Sraban says, thanks, Dennis. You're welcome. Thanks for coming. Lakshmi, thanks, Dennis. Learned a lot from today's class. Great. Nazish says, thank you, Dennis. Your session was really what to learn if the goal is to work in the industry. Yeah, Ashish, that's what I'm trying to do here, right? I love the book, but not everything in the book is real world. I'm trying to give you guys the real world. I'm trying to give you that because I don't think anybody else out there is qualified to do this, right? A lot of the influencers out there, they just haven't worked in the real world, right? Or they're fake videos, right? Because you can make stuff on ChatGPT and do the faceless videos and all that. But yeah, I'm giving you the real world answers. All right, guys. So I'm looking at the chat is slowing down. Thank you so much for joining me. We went for more than 2.5 hours. I know some of you were here from the very beginning, so good job, guys. You're showing me that you really want to learn if you're here for the whole session. So thanks so much. Really appreciate your support. I have fun doing these. So it's still summer. It's hot out there. So stay cool out there. Take care of yourselves. Take care of your families. And I'll see you next time.